Energy Security and Climate Change, a 71-minute presentation held at the Lefroy Lecture Theatre at the Defence Academy, Shrivenham, on the 14th of May 2008. The speaker is Professor Phil Hutchinson, who was Head of Engineering Sciences Division at the Harwell Laboratory of the UK Atomic Energy Authority, and later became Deputy Vice-Chancellor of Cranfield University and Principal at the Royal Military College of Science before his retirement in 2006. Professor Phil Hutchinson.
It is my hope to educate you a little on climate change, but also to offer a counter view to the dreadful pessimism that the eco-religions have tended to promote in society, suggesting that all is doom, gloom, that technological civilization always damages the environment and we must retrench. It's a sort of guilt about being human, and I think we need a friends of the people as well as a friends of the earth. The broad philosophical stance is summarised on the first slide, and on all of the slides I try to give a reference so you can follow up from the podcast if you wish. So it's broadly an optimistic view about what's going on. The sorts of questions that I want to discuss are: is there an energy crisis? Is there a shortage of energy? In particular, is there a shortage of hydrocarbons? Are hydrocarbons profoundly damaging to the atmosphere? What might we do if they are? What might we do to assure ourselves a reasonable supply of hydrocarbons for the future? And are there threats to our national security as a result of shortages of hydrocarbon or damage that the use of hydrocarbons causes to the environment, which could lead to societal difficulties? Well, as you can see from this first slide, we have continued to be able to find and fuel ourselves with hydrocarbon, and the projections suggest that that will go forward. The projections take a broad account of the appearance of India and China on the economic scene, contributing to growth. And for the term shown on the slide, which is up to about 2030, there is no significant real alternative to fossil fuels which involve emitting CO2 in their use. So whatever people might seek to do on CO2 abatement, in the absence of a radical reduction in standard of living and in growth, the CO2 emissions will continue to rise. This shows the very broad distribution in fuel use and how it's developed. As you can see from the bottom three segments of the graph, the energy usage is absolutely dominated by hydrocarbon combustion. The top end, which is hydro, nuclear, and the barely visible line, which is renewables, so the sort of base that you may need to start from if you wish to indulge in fuel substitution. It has a tremendously long way to go to be able to substitute for the hydrocarbons that we currently use. An interesting parameter in any economic debate about fuels and energy is the efficiency of economies in using fuels to produce GNP. And that's what this slide shows. It shows that, in fact, the UK has a pretty energy efficient economy already. It's the second one in from the right as you face the pale blue one. India is the one below that, but that reflects the fact that their GDP is dominated still to a large extent by human energy sources, where people ride bicycles about and carry things rather than using oil. It might surprise you when you look at the left, because there's Norway. And Norway is hugely energy profligate in producing GDP. And that's because a very large content of their GDP is oil and gas exports. They don't burn too much of it. They sell it so that others can burn it, make the CO2, and sell them the electricity back, because they have a cap on CO2 use, which has no effect at all on global CO2 emissions, but makes them feel good. Is there a shortage of energy? I find this probably the most persuasive picture that I have seen on the subject. It comes from the sceptical environmentalist, and what it shows at the top is the very tiny annual world consumption as compared with the big white box at the bottom, which is the annual arrival of solar energy. And in that comparison lies the clue to the future. In the long term, I believe it essentially certain that we will move to an economy which is dominated by the use of solar energy for our energy supply. What's missing is the technological bridge, and I'll come to that towards the end of the lecture. But meanwhile, the annual consumption is relatively small compared with the known reserves of oil, gas and coal, particularly since those are known rather than estimated reserves. In the hydrocarbon business, the amount of reserves is a financially highly contentious matter. If you ask an oil company what their known reserves are, they will be very cautious in the way they answer you, because if they have a lot of reserves, it'll put the value of the company up. If they claim not to have many, it'll put the price of the oil up. And so there's a middle ground where you want to claim reserves so that you keep the price at a good level and maximise the value of the company. So if the oil company said they had an infinite supply of accessible reserves, they would probably be worth zero and the company would be worth nothing. It's like taxation. 100% gets you nothing. If they say they have no reserves, but it's worth a lot, the company's still worth nothing. So somewhere in the middle lies the answer. And of course, the volume of reserves is determined by the diligence with which you look for them. And looking for them and establishing them costs money. And you don't put that investment in earlier. And that's illustrated quite nicely by this next pair of slides. On the left are the years of consumption given the current consumption rate. And you can see that wobbles about but stays rather constant. And that's because what happens is that the oil companies look for oil so as to maintain a reasonable horizon of reserves. And that means they don't need to spend the money until they need to. The second graph shows the known reserves as compared with annual production. And so you can see there's rather a lot of known oil reserves without having spent extra money to find more. And it is the case that when that money is spent, more oil is found. You will see from time to time on the TV and elsewhere announcements of new oil finds. And part of the reason why we find it is we can drill deeper and deeper in the oceans, which cover a very large part of the world's surface. These show similar graphs for gas and coal, and what you can learn from these particularly is that there's not all that much gas known, but there's probably a great deal more to find, but there are huge established coal reserves. But of course coal has a lot of carbon in it. One of the key problems with oil is not its availability, but where it is. And what this panel shows is a whole series of different people's estimates, that's what the 5 different coloured bars are, about where the oil is. And what it shows is that most of the oil is in the Middle East, not very much of it in the OECD. And that is indeed a problem in terms of security of access and supply rather than knowledge of availability. This table shows who produces the oil and who uses it. You can see that America is still a reasonably sized producer, but is now an enormous user. It really does consume a vast quantity of oil, but they can find it and pay for it and therefore use it. The price is going up just now because 2 new economies have begun to compete for the oil, particularly India and China, and there has not been sufficient refinery or drilling capacity installed to meet the full need at the old price. So the price began to rise. But there is a massive imbalance in the distribution and availability as compared with the use of oil. So the developed economies are, by and large, substantial oil importers. Similar story for natural gas. But when we come to coal, the story is very different. The established coal reserves are very broadly spread, and there are large volumes of them in the OECD countries, in the developed West. So we have to ask ourselves some very serious questions if we plan to deny ourselves the use of that coal because of its carbon emission. So here we summarise it. So oil will be a persistent problem, security of oil supply, until there is a political settlement in the Middle East. And I don't see any sign of that soon. There are much greater experts on that issue than me. Gas reserves are concentrated in the Middle East and Russia. Russia is making quite unfriendly noises to some of its gas customers these days, threatening to turn the supply off and to push the price up. But coal is widespread and large. So what can we conclude here about energy security? Well, energy security is an issue for those nations which consume more energy than they have available from indigenous sources, because they have to look outside. And the affected group, I say here, includes, but in fact probably is dominated by the USA and the European Union. We have become so dependent on energy to maintain our standard of living, it's rather like having the energy of several servants each to maintain us in the style to which we have become accustomed rather than would like to become accustomed. And if we can't do that, then we will suffer savage economic consequences, and as a result of that, savage security consequences. And that's economic and national security. So we can conclude that wise governments will take energy security to be a major policy issue. And as I said at the beginning, in the near term, hydrocarbon fuels will remain the primary energy source as the energy infrastructure is built around them, and we don't have other available technologies to help us out. Now, as long as markets work, the old Japanese energy policy, which was to be able to pay the prevailing price to obtain the energy supplies that they need, is a perfectly sound one. But unfortunately, the regional concentration of oil and gas reserves poses a serious threat to orderly markets. And that's not a piece of fanciful speculation. We have had oil supply disruptions to frequency of about once every 10 years over the second half of the 20th century. They're listed out there and shown graphically here. You can recognize them as major political events. The Iranian Revolution, for example, the Six-Day War, the Arab oil embargo, and more recently when Iraq invaded Kuwait. What happens to prices in those situations is that as supply tightens, the market works, price rises, speculators move into the market which exacerbate the price rise, and then fear overtakes greed, and people begin to sell off the reserves, and there are rapid falls in the price of oil. This graph goes up to 2005. Just at the moment, we are a little bit short of the past major price peak in dollars. We are substantially short of it in pounds. As you can see, the past price peak was $110-ish, $110 per barrel. And if you take account of inflation between 2005 and now, you'll see that that would equate to about $125 to $130 a barrel now. And that's where it is at the moment. But of course the dollar is worth much less than the pound these days. The dollar has fallen strongly against the pound, and so in terms of prices in pounds, we are probably still 20 or 25% below the previous peak. And the international currency markets will take account of all that. In fact, part of the reason for the high dollar price of oil is the weak dollar. You will remember that the folk in the Middle East wanted to reprice in euros recently, and Mr. Bush spoke sharply to them, and they changed their minds. But nonetheless, that means they simply let the price go up so they achieve their end, because they're being quite recalcitrant at the moment in terms of refusing to pump more so as to bring the price down. So what can we do in terms of energy security? Well, clearly we should take political action to preserve orderly markets, and that includes war as the normal extension of politics. And you might argue, and probably would have some truth in it, that the invasion of Iraq was in part driven by oil interest as well as the other political things that were courted. And while many people would object to that, I think it is a perfectly rational thing for a civilization to do to protect its own interest. We've always done it. Humans are very badly behaved when it comes to core interests. We can work on improving the energy intensity of the economy, and there's a lot to be won there. Rational conservation probably would contribute somewhere between 20 and 40% of saving of the fuel that we currently use. We have a lot of poorly insulated houses, we have a lot of congested roads, we have inefficient use of heated space in commercial premises. So there's a lot to be done there, and old heating installations can be upgraded. It also suggests that in terms of energy security, we should diversify our fuel use, and that would mean an increased use of coal in the hydrocarbon sector and possibly oil shale. You can build reserves to make sure that you have guaranteed minimum supplies. Until recently, the UK had very little in the way of gas reserves, so that if the Russians cut the gas off, or cut the gas off to somebody who then cut the gas off to us, we would have very quickly got into trouble. There is a slow rectification of that going on. You notice that there was a strike at an oil installation in Scotland, which shut down the whole of the North Sea because it's the single landing point for North Sea supplies. You wonder about the wisdom of a government managing its infrastructure that allows that simple pinch point to develop. I mean, it could be, though I don't suggest it is, that somebody had taken a forward position on oil futures and it suited their book to have an interruption of oil supply. Who knows? But that's a disgraceful speculation. We can develop indigenous supplies. The rate at which oil is sought in the North Sea by the oil companies has diminished recently because of an adverse shift in the taxation balance. So we now have fewer proven reserves in the North Sea and hence fewer accessible reserves because the infrastructure hasn't gone in because of what, in my opinion, was a very unwise change made by the present government in the taxation of oil companies. We can also develop renewables. We have lots of windmills, but they have particular difficulties in integrating the intermittent electricity supply into the grid, of which more anon. I've already covered the stimulate oil and gas supplies. We haven't done it, and we should. But our supply problem will be greatly exacerbated if we deny ourselves the use of high-carbon fuels like oil, shales, and coal. And last, and probably most importantly in the very long term, is we need to develop a reliable long-term energy source and the associated technology. But there is very little in the way of national money going into that. There is a significant amount of private money going in America, but not in the UK. And perhaps all of that arises because just at the moment, the UK is actually in quite a strong position, though it's deteriorating quickly. When I wrote this slide a year ago, we were self-sufficient in oil and gas, but only just. We are now a net importer, though that may be corrected if there's an economic downturn. We still have a good mixed package for electricity supply, using coal, gas, nuclear, but not much oil. And we have enough generating plant to meet peak demand. But that really is quite ephemeral. There is quite a substantial danger which is now upon us, and that is the close down of the old nuclear plant, beginning with Magnoxes and moving on through advanced gas-cooled reactors, with the last man standing being the single PWR that we built some years ago, which will last us till 2030. But this really is the nuclear cliff. And these stations will close down at that rate. The plans are already in hand, and there is no nuclear build available or likely to come on stream before these shut down. And that accounts for about 15% of UK generating capacity. This shows the indigenous production of primary fuels falling away because the rate of search fell away too. The oil companies took their technology and went to other parts of the world to look for oil where the taxation climate is more appealing. And we are now a net importer. So the risk of economic damage from supply disruptions is actually a much more imminent and pressing problem than climate change. It's upon us at the moment. There is a supply disruption in the oil market which is causing prices which will cause damage to the UK economy. It will appear as inflation, was an announcement today by the Bank of England, and we'll become progressively more susceptible to this type of disruption as the nuclear capacity closes down and indigenous production falls away. Now, the renewables that are pressed forward have only really two serious components. One is wind power, and wind power has no capacity to replace more than about 5% of the national electricity supply because it's intermittent, and that intermittent supply causes instabilities in the power grid which are not capable of being managed at the moment. And in Denmark, for example, where they were early into wind power and have more of it than we do, are now stopping the connection of wind turbines to the grid because it has a tendency to cause it to trip out. The only other credible renewable is a generator barrage across the Severn Estuary or across Morecambe Bay. That'll take a decade or more to come on stream, and so renewables will not deliver for us. So we do face the possibility of brownouts. I think the first will occur in 2010, but it may be of a different type than comes out of the wall socket. And so what we appear to have at the moment is a carbon policy and not an energy policy. The UK energy policy seems to me to be based on faith in renewables, which I believe to be misplaced, hope that there will be no disruptions in the Middle East and that the Russians won't turn the gas tap off, which I also believe to be misplaced, and otherwise to look for charity from those who are better prepared than we are, such as the French, with their large nuclear programme. The prime thrust of British energy policy over the past few years has been the Stern Report, which was promulgated as a call to arms to spend large amounts of money urgently on tackling the consequences of global warming, which may or may not become apparent in 20 or 30 years' time. I have on the screen a summary of the first of two articles published in the World Economic Review, which produced a scathing rebuttal of, first of all, the basic premises and assumptions of the Stern Report in terms of science, and secondly, in terms of economics. One of the authors of the science report is one of the individuals quoted by the IPCC as being fully in support of their view. He has been struggling for some time to have his name removed from the IPCC final report, which is essentially a political document and not a scientific one. I won't go through them in detail, and the references are on the top. The second report, which is the economic one, again savagely dismantles the assumptions in the Stern Report, which claim to argue that it is more economic to spend money early now to offset the effects of climate change than it is to wait and either adapt or correct when they become apparent. Again, as you can see from this panel and this one, distinguished economists, including Lord Lawson, the former Chancellor of the Exchequer, profoundly disagree with that and argue that the discount rate was set far too low for realism, and indeed that any sensible and respectable analysis would have done a sensitivity analysis to see at what discount rate the decisions fell the one way or the other. That's what an engineer would do and what a respectable economist would do in the face of uncertainty. So, from my perspective, again a contentious report, I believe that to be worse than worthless. It is a misleading document. It is a call to alarmism, and I hope will be abandoned. Not much has been said about it in recent times, and maybe it's just being buried as it's indefensible. So having looked at the security picture, where I would argue that from a reading of today's newspapers, an early part of the threat is already upon us, let's turn to global warming and what I call the warmest argument. The warmists are those people who have a religious belief in human-induced global warming. And on this panel, I have tried to summarize their arguments, and I will try now to show you why I believe they are unsound. So the argument goes that human use of hydrocarbon fuels causes carbon dioxide emissions. Absolutely true. It further goes, carbon dioxide is a greenhouse gas, and I'll show you what that means in a minute, and as a result, it causes a trapping of solar radiation. Absolutely true. As a result of that, the Earth gets warmer. Again, absolutely true. They then go on to say, we have increased atmospheric carbon dioxide concentration by about 40% since 1850. And if we go on as we are, we will increase it more. because most of that increase has happened since the middle of the last century. And that also is absolutely true. But then comes the false step. And the false step is to say, because we've put up CO2 a lot, and because CO2, they say, is the primary greenhouse gas, we should expect to see substantial rises in temperature as a result of these emissions. That is false. It's false because you can actually do the physics. The equations are very well established. You don't need a lot of climate models to do the physics of what happens if you increase CO2 by the amount specified in an atmosphere with the composition that we have, and you can get the answer. A colleague of mine called Bjorn Magnusson has done the calculations as well. And the answer is, with the present increase in CO2, we would expect about a 0.5 degree centigrade or 1 degree Fahrenheit increase in temperature. Now, why is that? Why is it that the warmists say, gosh, it'll be 10 or 15 degrees centigrade? Well, what they have to invoke is an argument that says, when it gets a little bit warmer as a result of the carbon dioxide, what happens is the water cycle in the atmosphere changes significantly. The dominant greenhouse gas in the atmosphere is not CO2, it's water vapour. And the human contribution to water vapour is almost negligible. But what the models do is introduce a series of correlations which lead to an amplification of the content of water vapour in the atmosphere. Now, regrettably, what they fail to have is a proper model for the behaviour of water vapour in the atmosphere. Because water vapour in the atmosphere, as we know in England well, and in Wales particularly, leads to rain. And the rain comes from clouds. And in terms of clouds, it depends whether they are high or low as to whether they cause extra warming by trapping heat or extra cooling by reflecting sunlight. And the current models are completely incapable of predicting that. And so what they do is what all engineering people do when you don't know the answer, and that is you put in a correlation. But anyone who has done engineering for a living, or computational fluid mechanics as I have, know that the results of calculations which are based on correlations are usually only reliable when they can be calibrated against existing data and are profoundly unreliable when used in extrapolation. So while the climate science that's going on is very well worthwhile and should be pursued, I have no doubt of that, we should look for an answer. To use it to make decisions which will affect billions of pounds of spending is ridiculous. Let's just take a look at things in a little more detail. That's a plot of the undisputed increase in concentration of carbon dioxide in the atmosphere. Carbon dioxide has certainly gone up. However, it hasn't gone up in proportion to the emissions. You can see the bottom graph is the rate of emission, and the top graph is the accumulated CO2. So what's happening is there is an adaptive response in the global system, because when you push out more CO2, one of the very beneficial things that happens is plants grow more effectively. So a good deal of the CO2 will be absorbed in increased growth of plants, helps the food supply. I mean, there is a set of figures which I haven't put in the lecture, which argue that the net effect of increased CO2 emissions will be beneficial to humanity, in the sense that it improves agriculture quite substantially. And there's historical evidence that that was so in the past. So while the CO2 has gone up, in terms of emissions, not as much has been accumulated as has been emitted. So some of it's gone round in the cycle and been trapped again. This is a very schematic sketch of the behaviour of incoming solar radiation and where it can go and where it can't. The calculation that I described to you, saying about 1 degree Fahrenheit, is a calculation which is heavily simplified and probably pessimistic in the sense of expecting a higher temperature rise than would be present if there were lots of clouds about reflecting solar radiation. So you have to pick your pathway through that, and as I've already said, the physics of cloud structures is not particularly well understood. This picture shows how the greenhouse effect works. What happens is that incoming radiation from the sun is balanced towards the shorter end of the radiation spectrum. That's the near infrared. That's because the sun's hot. When things are hot, their balance of radiation comes out at higher frequencies and shorter wavelengths. When it arrives on the Earth, some of it is re-radiated, but the Earth is considerably cooler than the sun, otherwise we wouldn't be here. And so it's re-emitted at longer wavelengths. That's the reddish area on the right. When that re-emission occurs, some of it, about 8%, can be trapped by carbon dioxide, because carbon dioxide absorbs thermal radiation, but it doesn't absorb it across the whole spectrum. It absorbs it in absorption bands, and the absorption bands can only see about 8% of the radiation coming from the Earth's surface. And it is arguable from one set of calculations that the maximum amount of radiation that can be trapped is already being trapped by extant levels of CO2 in the atmosphere. Now, if that is true, the addition of further CO2 will have no material effect on the temperature. So it's like shooting marbles through railings. Lots of the marbles go through, the railings are narrow, the ones that they hit bounce back. That's the greenhouse effect and solar trapping. So let's go back then and say, well, but surely that still would be quite important, because CO2 is claimed, after all, to be the major greenhouse gas. But no, it isn't. CO2 is a very, very tiny component of the atmosphere. It's now 370 parts per million by volume. When we started off in 1850, it was about 270 parts per million by volume. The big component in the atmosphere which has a major greenhouse effect is water, and it's about 2% of the atmosphere. This shows the contribution to the greenhouse effect from the atmosphere as distributed, and it tries to separate those components which have arisen from human effect, and as you can see, the light green band on top of the water vapour is pretty small. CO2, where the human component could be significant, but is likely to be a very small contributor in the overall scale of things. And so this now explains why it is that if you do a straightforward calculation of the contribution from CO2, you find a much smaller effect than is argued for by the warmists. Because what the warmists try not to tell people is that they require an entirely speculative coupling between water vapour and CO2 in order to generate the large effects that they propose. Now we can look back a long way in history and say, well, what about it though? Suppose CO2 gets terribly big, won't it be dreadfully damaging? People dig up ice cores and have all sorts of fancy techniques for getting measurements of the historic temperature and the historic CO2 composition. And what this particular graph, which goes back 600 million years, so verifying the ancient data could just be a bit tricky, shows is that there is little or no correlation between CO2 in the atmosphere and global temperature. It's much more likely, well, it is certain that some of the atmospheric variations occur from variations in the Earth's orbit around the Sun. There's a well-established cycle computed for that. But from things like the Panama Isthmus rising and cutting off the Pacific circulation from the Atlantic, which is thought to be the cause of one of the major ice ages. So there are large things going on in the climate and in the world which are much greater than our rather puny contribution from CO2 emissions. And it really does suggest that if we were smart, we would spend as much time trying to manage the climate as we do trying to manage earthquakes, tsunamis, and other natural events like volcanic eruptions that are beyond our control. It suggests that we need to learn how to live with it. Where did the hysteria come from? Well, this particular panel shows two graphs. The top graph is a now completely discredited plot of global temperatures versus time. It's the so-called hockey stick graph, which shows a rapid acceleration in temperature in the last half of the last century. It was published in Nature, but escaped the review process. Fortunately, a diligent Canadian statistician went and reworked the data, and what he's demonstrated is that no matter what data you feed into the fitting program used to generate that graph, it always produces a hockey stick. You can feed in random numbers and you'll get a hockey stick. And a rational analysis goes to the graph on the bottom. And what that does is restore something that we all know about, which is the medieval warm period. Why do you think there's a place in Abingdon called the Vineyard? It isn't because they grew apples there. In the past, in the UK, there was a very substantial viniculture, and that viniculture prospered during the medieval warm period, which was very good for civilization, is well established and well known. And if you look at the picture now, it would tell you there is no cause for alarm, because we have not yet got to temperatures which are as warm as they were in the medieval warm period. And yet the polar bears survived that. Good heavens, I thought they would have been extinguished. If you take the data that Gore shows in his disgraceful film, where he, with a brandish, says, look, CO2 is correlated with temperature. First the CO2 and then the temperature. Unfortunately, his graphs are the wrong way around. Fortunately for him, fortunately for us. Because what happens is that the CO2 follows the temperature. And the reason for that is relatively easy to understand. When the temperature rises, the solubility of carbon dioxide in the ocean reduces. So the oceans slowly emit CO2. It takes a long time to warm the deep oceans, and so they emit it slowly and in a following way. As the temperature rises, the tundra in Russia will emit CO2. So there is a correlation between temperature and CO2, but unfortunately for the warmists, the correlation is when the temperature goes up, the CO2 follows. This graph, the bottom one, appeared in the first IPCC report. It has been suppressed in subsequent publications. And what you must remember is that the IPCC summary report for governments is not a scientific document. There is a scientific annex which is then interpreted for the political report which is given to governments. And quite a number of distinguished contributors to the background report have fought long and indeed through the courts to have their names removed from the political report, which is, a kind expression would be, mendacious. The other thing that the media produce quite often is a statement that we've just had the warmest year since. Now again, the same Canadian statistician tackled the NASA data which purported to show that the warmest years of the last century occurred in the 90s. As a result, NASA has had to concede that several of the warmest years of the last century occurred in the 30s. This particular plot shows the frequency with which temperature records are broken. And as you can see, there's a big peak down in the 20s and 30s, tapering out a bit in the 40s. So there is nothing exceptional in the fact that we break records now and then. As a statistical sort of person, I can tell you with normal distributions, that's quite usual. This picture shows satellite data which measures the average temperature on the surface of the Earth from a point just below the North Pole to one just above the South Pole. The viewing window is generally accepted to give a reasonably reliable and accurate guide to global temperatures. The data begins in 1979, wobbles around, shows a sharp peak in 1998, and the most recent data for 2008 shows a sharp fall. Over the period 79 to 2008, there has been a very small rise in temperature, consistent with the temperature rise you would expect from CO2 contributions only. The sharp peak in 1998 was very widely reported in the media. There has been little or no reporting of the fall in 2008. There was a disgraceful incident where the BBC amended its environmental editor's comments on the website, which pointed out that this might contribute to scepticism about global warming in response to pressure from environmental groups. This again was widely reported in the USA, but not at all in the UK. You can see that the data shows there has been no rise in temperature over the last 10 years, and indeed on a peak-to-peak basis, a substantial fall. So the warmest argument's taken hold, and I think the issue is something to do with the herd instinct in humanity. And what has particularly happened, I think, in the UK is that small but particularly influential group were converted early, and their power has promulgated the view, and there is an attempt to suppress argument. One distinguished member of the Royal Society, now the Master of Churchill College, on behalf of the Royal Society, wrote to the newspapers asking them not to publish arguments or articles which were critical of the warmest position, since they believed it would be damaging. Now that is an appalling failure of the institutions related to science, the primary institution related to science. The Academy of Engineering has recently espoused the warmest position on the basis of no reasonable argument that I can see. So once all the dust settles, and if it seems likely, the next decade turns out to be rather chilly, for reasons that I'll come to in a little while, we really need to look again at our institutions and be concerned about the extent to which the Royal Society and the Royal Academy of Engineering have become politicised and therefore are failing in function. Here's an interesting plot from that well-known hotbed of scepticism, the Natural History Museum. What it shows is very broadly a plot of temperature. It's a temperature indicator. And what it shows is that, yes, we're coming to the end of a longish warming cycle just now. The graph is so compressed because the bottom of it is at 700,000 years ago that seeing the last century is a millimetre of the graph, so you can't see local variation. What it tells us, if we examine when humanity was present or absent from the UK, is that cold periods are much more threatening to human existence than hot ones. There are 4 times when humanity was absent from the UK, always because it was too cold. Other anecdotal evidence that you can find in the literature shows that Roman civilization flowered in a brief warm period in the past. So is there another plausible explanation as to what might be going on? The answer is yes, there is. And it's one that passes the common sense test for me. It says the effect is primarily due to the sun. Now, if you remember the picture that I showed you at the beginning, it showed that the amount of solar energy arriving at the Earth is hugely greater than the amount of human energy use. And what this particular group suggests is that global warming occurs as a result of solar events. The sun emits a solar wind, and the solar wind is radiation and particles which press out from the sun. And as they press out, they tend to interact with and deflect cosmic rays. So in periods of high solar intensity, the solar wind tends to inhibit the arrival of cosmic rays in the atmosphere. Arrival of cosmic rays in the atmosphere tends to promote the formation of cloud. When clouds form in the upper atmosphere, they reflect more solar radiation than arrives, so you would expect that if their arrival was inhibited, that it would get warmer, and that would also coincide with a period of greater solar activity. So the argument is that the solar wind blows the cosmic rays away, that inhibits cloud formation, it gets hotter. And it's quite speculative. You can again adduce anecdotal arguments if you look at pictures from the great masters in the past. When it was chilly, you see they're always painting with lots of clouds in, but that's anecdote. But what about data? Well, here is some data which plots low cloud cover and cosmic ray arrival. And there's a reasonable correlation. The interesting thing is that if you believe this theory to be true, it predicts, as a result of the development of the solar cycles, that we're in for a chillier time. On here is a long list of failures in the warmest argument. But I think I've given them enough space, and there are references. So, in short, there's no climate crisis of any kind at work. Let's step aside from that. I don't believe in anthropogenic global warming as a major contributor to the climate, but suppose it was true. Let's ask, if it was true, what would you do? Well, you would reduce carbon emissions for sure, and you would do that by increasing energy intensity. That must be a familiar thing. You would diversify supply by using renewables and nuclear, a familiar thing. You would limit the use of high carbon fuels or require carbon capture, and that, as I've shown before, would cause us to back away from the use of coal and oil shale, perhaps with serious consequences. You would cut economic growth by rationing carbon. These are all being developed. You would develop a reliable, long-life, carbon-free energy source, as I'll show that's likely to happen anyway. And little mentioned on the list, you would adapt to the new circumstance. Now, one of the ways of responding, given on that chart, is to sign up to the Kyoto Treaty. Kyoto Treaty sounds very good. What you would do is ration carbon, you would inhibit consequences, but you would take a hit on your economic growth. And depending on what you assume for long-term economic growth, you can work out the consequences of Kyoto, because Kyoto would cost between 1 and 2% of GDP growth if it were implemented. And so, in a century, you can then use the compound law to work out how much GDP growth you would lose. If you only cut growth by 1%, you would lose just a bit more than 2.5 times our present GDP in lost growth. So you would have suppressed the standard of living at that time substantially. If you're unwise enough to cut by 2%, it'll be 7 times. And what's the benefit? Well, the benefit is the difference between those two lines. If everyone fully implements Kyoto, you delay the impact of carbon emissions and global warming by about a decade. And that tells me that the people who are promoting the Kyoto Treaty and its successor haven't thought it through, because there will be revolutions before they get a century into it. People will rise up and throw them out as they begin to see the serious losses in the economy which come from a foolish policy. But again, you might ask the question, is it necessary? Well, the warmists are predicting between 2 and 8 degrees of rise in temperature. What's the global spread that humanity has adjusted to? As you can see on this particular case, the average temperature in Akron, Ohio is 50 degrees Fahrenheit. In Daytona Beach, Florida, it's about 70. So humanity has already been able to adapt to much greater temperature changes and climate changes than are proposed. And this massively, in my view, undercuts the argument for spending loads of money on carbon abatement. Again, you can see we are a bit deceived in the UK because our climate swing annually is quite small. It's only 2.5 degrees. But in America, it's 21. So adaptation's possible. What's the common ground between the two sets of issues? Well, you can see that there are 3 key areas. Increasing the energy intensity of the economy, diversifying supply, but it would not be common ground to diversify by using coal and oil shale, and developing a long-term, reliable energy source. What might that long-term, reliable energy source be? Is it all hopeless? Have we not a chance of doing anything about it? Well, actually, the situation, to me, looks quite profoundly optimistic. The best option for the long-term and incidentally carbon-free energy source is solar electric. And the good news, because solar electric technology is a piece of material science and solid-state physics, where there tends to be rapid development and rapid reduction in costs, is falling in price at about 50% per decade. And if that's maintained, the crossover with fossil fuels in terms of price will occur around the back end of the first half of this century. I mean, the numbers are very speculative because you're looking at crossing lines where one's fossil fuel prices, and I'd be very rich if I could predict those accurately, and the other's the solar price. At 30% a decade, which is a fairly pessimistic sort of view, we don't get there till the back end of the century. Now, when that happens, there will be quite a geopolitical revolution. It also, I have to say, the caveat is it needs a reliable storage technology, but again, there are quite nice developments going on in battery technology. But that changeover will probably produce a massive economic dislocation, because the folk who make a good living from selling oil, and will by then be making a good living by selling oil at premium prices, will suddenly find their income sources drying up. And that itself will raise a whole interesting raft of security issues. So it's my view that by this time in the next century, the economies will almost certainly be driven by solar energy, either solar thermal or solar electric, probably mediated by synthetic fossil fuels. But that itself raises some interesting security questions. If it is solar energy that's dominating, where's the major resource? You should be able to get that pretty quickly. And who will dominate that solar resource? Will there be an imbalance in supply and usage? And what might the implications of that be for national security? What will be the impact on those economies that depend on oil revenues to maintain them in function? And who will be the beneficiaries and losers? And when might it happen? So, on that optimistic note that there is a solution which is likely to arrive before the worst fears of the warmists even might be fulfilled, in the long term, I think things will continue to get better, despite the wishful thinking of those who would think they'll get worse.
Professor Hutchinson was asked 9 questions. Question 1. The Hadley Research Centre at the Met Office addresses nearly all the points you've raised and takes the opposite view from the one you are postulating. Why is that?
You will recollect the picture from satellite data which shows that since 1998 the temperature has not gone up. So we're actually in a situation now, just to digress briefly before coming to answer you, we're in a situation now where the temperature hasn't gone up for 10 years. In fact, it's fallen. There was a particularly sharp fall this year. And the predictions are now that it won't rise for another 5 years. So why would the Hadley Centre come to that view? Well, I worked in the Atomic Energy Authority for a very long time, and the institutional view of the Atomic Energy Authority always was that the fast nuclear reactor was a desirable source of energy, even when almost all of the scientists inside the Atomic Energy Authority knew that that was untrue. And I think it's that sort of institutional failure that I believe is profound. I think that if the Hadley Centre looked at their own calculations, had they been done by somebody else, they would not reach the conclusion that they have reached now. People's employment, their careers, their scientific reputations are at stake. I mean, there is another notable example of when this happened in the past, and that was the eugenics debate in the 1920s, when eugenics was very widely espoused. People were sterilized, they were forbidden to marry, they were locked up on the basis of eugenic theories about how you maintain the purity of the race. Now, it sounds outrageous to us now, but at that time it was going on in America and it was going on in Europe. And I think it's that sort of religious set point. If I wanted to make a particularly adverse parallel, I'd talk about the scourging dancers in the Middle Ages who went on with irrational things. So I think the institutions have lost the plot, institutionally. I suspect if you could get some of the calculation people and get them to talk about what the real susceptibilities are in their calculation, you would know that. I mean, I worked on computational fluid dynamics in the early days, and we had a very interesting student who could always predict the data. And unfortunately, and entirely by accident, he was once given some flow data where the inlet had been transposed with the outlet, and all the flow directions had been reversed. And he predicted it. And then we gave him the correct data, and he predicted that too. And what he was doing was fiddling about with fitting coefficients, and much of the climate calculation is based on fitting coefficients. The stuff for two-phase flow, for clouds, and all of that sort of stuff is not based on scientific calculation like the Boltzmann equation for the radiation. And so you can fit the data. But when you try to fit the data and then extrapolate it, it's very dangerous. It goes back to the old Club of Rome. Remember the Club of Rome, of which Lord Mays was a great exponent, and indeed, I'm told by Lord Lawson, he called Lord Mays a serial alarmist in the House of Lords debate on global warming, that Lord Mays objected to that, and that Lord Lawson simply reminded him of his support for the Club of Rome hypothesis and has heard nothing more. Those graphs produced all sorts of alarmist things. They showed we'd have run out of energy in the early 90s, we would have depleted many metals and rare earths. None of it came to pass. It was very bad extrapolation. So that, I think, is why. It's the separation between the science and the institutional belief.
Question 2. How is it that none of the computer modelling has picked up the present static temperature for 10 years and the projected cooling period?
Well, they have, that their next grant is at stake. So what they'll say is, yes, we expected that. That's a local climatic variation. And so there's been a recent publication from a German group that says, we expect it to get cooler over the next 5 years. It's the El Niño circulation in the Pacific. So yeah, if you've got the data, you can always fiddle with the model to predict it. The trick is to be able to predict forward and stick by what you predicted. And they didn't.
Question 3. We have known about our energy insecurity for a long time, but there was a great belief that nuclear fusion would solve all our energy problems. What has happened to that?
Well, what happened to the nuclear case was Chernobyl. Chernobyl frightened people so much that there was a huge pullback from nuclear. The atomic energy nuclear argument can be very simply put. This is the 1950s argument. It said, nuclear reactors have very low fuel costs. Once you've built them, it's essentially free. And there was the great promulgation of free electricity. In fact, what was going on was that the Magnox reactors were being built to provide plutonium for the weapons program. And so they needed to be got through rather quickly. But the argument wasn't too bad. And the big mistake was that the economics and cost analysis had been done by a bunch of physicists like me. They really should have got in a bunch of design engineers and a bunch of economists who would have talked them through the real costs of operating a nuclear plant. And what then would have been discovered was that the costs of Magnox thermal nuclear were a bit less than the cost of coal-fired electricity at that time. But what they hadn't reckoned with was people's huge risk aversion in the nuclear area. People will agree to spend, or will wish to have spent, very large sums of money to take care of events which are exceedingly unlikely. The normal way to calculate a safety risk is to take the probability of the risk occurring and multiply it by the consequence of that risk. And that gives you an expectation for the economic damage. And if that was the case, if you stuck with that, then the costs of nuclear installations would drop, probably by about 50%, I would think. But people aren't happy with that. If the event, which is very, very improbable that might occur, is a highly radioactive release that will contaminate most of southern England, people say, well, even though it's very unlikely and the cost of that is tuppence, I'm not prepared to take that very, very tiny gamble. And so I want you to add safety systems to reduce that as close to zero as you can get. So modern nuclear reactors are wrapped up in safety wrappers to prevent that happening. And again, in part, that's a result of letting the physicists design them. Because if you give a physicist a heat engine to design, what they'll do is they say, right, I know that I get best thermal efficiency if I make the temperature and pressure very high. So I'll have a core with lots of heat in it, and I'll put a strong wrap around it to keep it in there. I'll get enormous thermal efficiency. That'll get the cost down. Bob's your uncle and Charlie's your aunt. Off we go. In fact, it's wrong. And when you do a proper systems optimization, you would go for a reactor system where if there was an incident, you would say, gosh, I really must get round to that about next week, because in 2 or 3 years something nasty might happen. Now, there are reactor designs like that available now. They are thermally much less efficient, but economically much more efficient. But the nuclear industry got itself into the bind of having a bad conceptual design, a poor economic and engineering analysis, and then, just as they were trying to work their way through that, and came out with the PWR, which has been a very successful design, the French have operated that for the last 30 years, Chernobyl occurred, and there was a general distaste for further nuclear adventures. Of course, oil prices were relatively cheap at that time too, and people veered away from it. And so the promise of nuclear has not been delivered, but it could be. But now, nuclear is not good at rapid response, so you need lots of peak locking capacity, and that tends to be difficult to get through in an open market for electricity. So I think nuclear will continue to have difficulties in an open market and will continue to need some sort of government subsidy. For myself, I think that a modest subsidy would be worth paying for that or other energy sources which would give us an assurance of supply. So rather than a greenhouse premium, I think it would be appropriate to have a security premium which helped shelter us from the adverse economic consequences of power system failure. But that's why it stalled in that way. It was economic and social events. What's happened since then is, I think, that governments concentrate on things that are biting them today. And for a happy period, we've had a very secure energy system in the UK. But there's been a profound lack of foresight, even though they've had on their desks the nuclear cliff table probably for more than a decade now, and have done nothing about it, have been disinclined. But of course, the present government had good reason to really dislike the nuclear industry, because it was the nuclear industry that kept the electricity supply going when Mrs. Thatcher defeated the miners. And there was a score to be settled there, and indeed they let Nuclear Electric go bankrupt when they came into power. So it's politics and people.
Question 4. Is nuclear fusion much safer than nuclear fission? And so could the costs associated with risk aversion be greatly reduced?
No, I'm afraid not. Nuclear fusion is intrinsically safe. That's certainly true. If something goes wrong, the nuclear reactor just shuts down, doesn't blow up. But the way nuclear fusion works is it whacks together nuclei of hydrogen to make helium. Now, when you do that, what happens is lots of neutrons come out, and the neutrons go cascading through the structure and make it radioactive, and they degrade its structural integrity. So there is quite a substantial irradiation from nuclear fusion, and it would mean that you would probably have to knock the reactor down and dispose of it every few years, and I don't know how many a few is, because it's a materials physics problem that hasn't been very well worked through. But fusion is not clean, and actually I think the technology is so immensely difficult that it will arrive later than solar electric. So it'll find special application in things out in space, I think.
Question 5. What is your take on the impact of melting ice caps?
Well, you need to separate between two ice caps. If the North Pole ice cap melts and nothing happens at all, it's like the ice in your gin melting. It's just floating water, so nothing happens to the sea level. If the South Polar ice cap was to melt, and it has in the past, but we're a long way from temperatures that would cause that, then there would be a serious inundation. But again, one of the slides I hadn't time to show shows that the rate of sea level rise at the moment is about 1 millimetre a year. And so, century by century, that's a couple of inches, so there is no evidence that that's happening. What's happening is that the South Pole is melting. You will see alarmist photographs which show great shelves of ice that have fallen down. That's cracking. When ice melts, it doesn't melt by dropping down in a shelf, it melts by melting off the edge. So that's a normal geological process. And the warmists are very adept at producing good media pictures of things to scare people. And in more cynical moments, I sometimes wonder if, you always need something to keep the population under control, and there's been a book or two on this recently. So what you do, frighten them with things. So you frighten them with things so they'll behave themselves. In the past, it used to be hell and damnation. Just at the moment, it's global warming.
Question 6. If the usual way that social control works is to scare people to get them to do what they want, how does this fit in with governments that implement the Kyoto criteria? If the expected pain from a decade of falling living standards is likely to lead to unrest and revolution, surely this is not what any government wants.
The key to understanding this is that governments have relatively short horizons. The pressure of politics in democracies is such that a long time is the time between elections, and the time between elections is of order 4 or 5 years. The second key to the argument is to note that an adherence to a belief, and I use the word belief advisedly, in global warming is broadly associated with governments of the left. Governments of the left like to find reasons for raising taxes, and global warming and the fears that it has been used to induce are an excellent way of pacifying populations when governments wish to raise taxes, calling them green. You saw the effect of this in the petrol blockades in the early part of this century, when the government overstepped the mark and the green argument wouldn't wash anymore. They then backed off, but more recently they have returned to the fray with proposed increases in fuel tax duty and retrospective taxes on large vehicles. The retrospective tax on large vehicles will have an almost zero impact on carbon dioxide emissions, but is brandished as a green tax. And so the short perspective of a left-leaning, high-tax government will lead it to espouse global warming as a useful ticket for pushing unpopular taxes through. There is also a very broad philosophical difference out in society now, as between the Greens, who believe that man should adapt to the environment and minimize impact on it, and the developers, who believe that we should continue as we have since time began to develop and manage the environment using technology. It is convenient for the Greens to produce alarmist scares ranging from flood, fire, and the extinction of species to prop up the argument of man's invasiveness and damage, and to obscure the impacts that this would have on human prosperity and standard of living. So that, for example, the money spent to implement the Kyoto Agreement, if it were to be spent, could instead be spent on providing fresh water to the poor of Africa and India. My view is that that would be a much better use of the money. It's also appropriate to look at the consequences of historic changes to the environment by the human race. The area in which we are presently speaking, Oxfordshire, was once a nasty swamp. Our forebears drained it and irrigated it and cultivated it to produce the very pleasant landscape in which we live today. It's my clear view that that is the process we should continue. We need to be smart at it, and we need to work hard to avoid unintended consequences, but we should not try to scare ourselves out of developing technology. And now, you see, we are in the unfortunate situation where very influential people who are in charge of companies and research institutes and university departments have their careers at stake. If these pronouncements are all wrong, there will be serious red faces. Previous chief government scientific advisors, the last one and the one who preceded him, would have to issue public apologies for giving misguided policy advice. Now, I'm sure that in the first instance they did it with good intention, but it's now self-reinforcing and winds itself up like any of these bubbles. And it'll burst. It'll take, I think, probably 5 or 10 years of really bad winters.
Question 7. Shrivenham has been under ice 50 times longer than it has been wheat fields. Are you saying that global cooling is the real crisis?
Yes, that's what the Natural History Museum graph tells us, that we should be much more concerned about global cooling than global warming. It also is part, I think, of a deeper philosophical argument. Essentially, the green argument is that we should moderate the effect of humanity on the ecosphere because it's wicked and it's damaging. And so we should adapt and moderate. And in one version of this lecture, I have a nice closing sequence where I show a dinosaur being hit by a meteorite. Because if you adapt and moderate, don't develop technology which will allow you to modify, control and manage the environment, then the next extinction event will take you out. Instead, an appropriate philosophy would be to say that what we are good at is taking control of the environment, adapting it to suit us, that we would be well advised to be increasingly skillful in that, so that we don't fall into unintended consequences, but to get on and do it. So I think that the core Friends of the Earth argument is foolish, damaging and dangerous, and that there is a need for a Friends of the People to counterbalance them. So I think it's one of the deep philosophical arguments, and it will need to be worked through over the next several decades. So I think the whole thing is sort of awkward. And what happens is you get people who are practicing greens in the same way some people are practicing C of E. And that is, they'll say they're green, but they don't do it. And if they had to do it, they would be in serious difficulty.
Question 8. How much analysis or experimentation has been done in collecting results from solar radiation? And is this continuing?
Now, there's quite a lot of work going on the solar radiation question. In fact, if you go and look on the web, there's a very good PowerPoint presentation by a professor, and I forget which department. I think it probably is mechanical engineering at Imperial. And it's quite a nice analysis of where things are going and reaches very tentative conclusions, as you would expect in a work in progress. But there is a lot of work going on in that. And in fact, there is the beginnings of a debate amongst the solar radiation people suggesting that we might be in for a decade or so of really chilly weather, hence the remark about 5 or 10 years of bad winters, because there is a well-established solar cycle. The solar radiation's passing its peak and will fall away over the next decade or so. So you can use that to make some set of predictions.
Question 9. Is there a body of opinion that supports your views?
Yes. Go on to Google and type in Manhattan Declaration, and you'll find a document which sets out, in rather close, tight summary, the things that I've said. I think the signatures on it now are in the thousands. And in order to sign up, you require a PhD.
Please note that the views expressed in this presentation are entirely and solely those of the presenter and do not necessarily reflect official thinking and policy of either Her Majesty's Government or the Ministry of Defence. Professor Hutchinson can be contacted by email at pp.hh@physics.org.